I share software testing techniques called a baseline-based BST design model for software testability. My summary is divided into five parts. The first is an introduction to the model. The second is how to construct the model. The third is the impact of the model on testing methods. The fourth is the impact of the model in the software lifecycle. The fifth part is the summary. Due to the increasing complexity of software systems, effective testing methods are needed. The article proposes a new approach to design software that can be easily tested for faults and errors. The model is based on the baseline BIST concept, which improves the efficiency and effectiveness of software testing by integrating self-testing mechanisms into the software itself. The model improves software testability, reduces the overall cost of the software cycle, and automates data analysis and test case generation. A baseline model refers to the minimum level of software testability that a project should achieve. This baseline is usually determined by a set of metrics or criteria, such as code coverage, test case execution time, defect density, and other relevant factors. By referring to the baseline model, development teams are able to access their progress and identify areas for improvement. The role of the baseline model. First, establish testability objectives. A baseline model helps to establish clear, measurable testability objectives based on the project requirements, constraints, and resources. These objectives should be aligned with the overall quality objectives of the project and ensure that the software meets the required level of testability. Monitoring and controlling testability. By comparing the software testability metrics to an established baseline, development teams can continuously monitor and control the testability of their software. This allows them to identify and deviation from the desired level of testability and take corrective action to improve it. 3. Accessing the effectiveness of BSD mechanism. The baseline model can be used as a reference point to access the effectiveness of BSD mechanism implemented in software. By comparing the testability of software before and after the implementation of BSD mechanism, the development team can assess its impact on testability and make improvements as required. The baseline model provides a basis for continuous improvement in software testability. As the project evolves and new information becomes available, development teams can adjust baselines and testability targets to reflect changing requirements and constraints, ensuring their software remains testable and maintainable. Why? Why introduce the BIST concept in software testing? The role of the BIST is integrated self-testing mechanism into software itself. BST mechanism can proactively identify testability issues and automate test execution and reporting, thereby improving the efficiency and effectiveness of software testing. Next, let me talk about the role of introducing BST. Proactive identification of testability issues. The BST mechanism helps development teams identify and resolve testability issues early in the development process, reducing the likelihood of defects and improving the overall quality of software. Second, automation of test execution and reporting. The BST mechanism automates the execution of test cases and reports their results, reducing the manual effort required for testing and allowing development teams to focus on other key aspects of software development. Third, efficient testing and reduced testing time. By incorporating self-testing mechanism directly into the software, BSD can help streamline the testing process, thereby reducing test execution time and lowering testing costs. For improved fault detection and resolution, the BSD mechanism can enhance fault detection and resolution by continuously monitoring the behavior of the software during execution. This enables development teams to quickly identify and resolve any anomalies, resulting in a more robust and reliable software product. The last, continuous monitoring and control of testability with the BST mechanism. Development teams can continuously monitor and control software testability metrics against an established baseline, ensuring that the software meets impact testability level throughout the development process. Building a baseline-based BST design model for software testability. The RTT, tester point design, tester construction, execution trail case library, and the system comparator. The implementation of the model must be based on the joint involvement of software analysis, code developer, and software tester. I have summarized the 6 steps needed to build the model. Define the reference template for testing, analysis of the baseline model, design a detection layer and detection points, building detector, develop a library of execution trail cases, implement a system comparator, integration of BSD into software systems. The impact on test methods. The baseline-based software testability BSD design model primarily influences the white box testing approach to the software testing process. Also known as structured testing, white box testing focuses on the internal structure of the software application, examining source code, control the flow, data flow, and the internal structure to ensure proper functioning. BPDM enhances white box testing by incorporating BSD techniques traditionally used for hardware testing into software development. This integration improves software testability through a structured approach to detecting points, building detectors, and using an execution trail case library and system comparator to compare actual results with expected results. By applying BPDM to white box testing, developer and tester can more effectively track, connect, and analyze relevant test information. This improved testability allows problem within the software to be more effectively identified and resolved, resulting in improved software quality and reliability. Why does the BPDM have a big impact on white box testing? I have summarized the 3 points. The first, BPDM improves testability by providing a systematic approach to identifying test points and building detectors. This detector enables developer and tester to track, connect, and analyze relevant test information, making it easier to identify and resolve problems within the software. The BPDM uses a layered structure to detect layers based on different baseline layers of data integration baseline operation graph. The structure allows testers to access layered testing information, enabling a more granular understanding of software systems and allowing for more effective testing. The BPDM supports automated testing and mathematical analysis using combination of execution trail case libraries and systematic comparators. By automatically comparing actual and expected results, the developer and the tester can quickly identify discrepancies, speed up the testing process, and reduce manual workload. The BPDM acts on the following major phases of the software lifecycle. During the design phases, the BPDM helps define testable software architecture by creating test reference templates, and designing test points. This phase lays the foundation for introducing testability mechanisms into software development process. During the implementation phases, developer integrate detector and test points into the source code in accordance with PPDM guidelines. They ensure that the software is designed with testability in mind and enables tester to track, collect, and analyze relevant test information. During the testing phases, PPDM comes into play guide tester on how to conduct effective white box testing using detection points and detector. Tester can use the layer structure of the detection layer and the library of the execution trail cases to automate and simplify the testing process. In summary, the baseline-based software testing testability BST design model is an innovative approach to software design that improves testability and reduces the time and effort required to identify and correct faults and errors. By using built-in self-testing, scenarios, and hierarchical design approach, the model provides a powerful testing framework that can be used throughout the development process. Thank you. Thanks for watching.